Alright, here's another video on finding arc length of graphs. And this time I'm going to be using trigonometric functions. So our problem is to find the arc length of the function ln of cosine x, which actually isn't very difficult, and our interval is from 0 to pi over 4. So, as any other finding arc length, we find the derivative is going to be 1 over cosine x times negative sine x, which so happens to be negative tan x. If you square the whole thing, as we need in our formula, it becomes tan squared x. Now we're ready to plug everything back into our formula. The arc length equals, from a to b, our intervals 0 to pi over 4, square root of 1 plus tan squared x dx. Now, 1 plus tan squared x is actually secant squared x. And the antiderivative of all of that is, if you remember, ln of secant x, of absolute value secant x plus tan x. And then you still have to keep your intervals 0 to pi over 4. If you simplify, or if you plug in the values, I should say, ln of secant pi over 4 plus tan pi over 4, probably going to have to write very small, minus ln of secant 0 plus tan 0. Now secant pi over 4, I'm going to use a different marker, is square root of 2. Tan of pi over 4 is 1. Secant of 0 is 1. And tan of 0 is just 0. And if we simplify all of that, you get ln of the absolute value still, square root of 2, plus 1, minus ln of 1 plus 0. With that, to put the equal sign here, ln of square root of 2 plus 1 minus ln of 1. Now the ln of 1 is just 0, so you get ln of square root of 2 plus 1. And that is the arc length for ln of cosine x on the interval 0 to pi over 4.